Welcome to Descriptive Statistics. This is Chapter 20. Our first lesson, we are going to learn about key statistical concepts, as well as measuring the center of data. Key concepts, especially in stats, we need to define our vocabularies first. So here's a list of key terms: population, census, sample, survey, data, categorical variable, numerical variable, parameter, statistic, distribution, and outliers. You can see from population and census is just a collection of the population. Survey is a collection of sample, but sample is within a population, right? You're taking a sample out of a population. So the information collected from a sample is survey, and the information collected from population is census. So it gets bigger that way. You also have data, categorical variable, numerical variable. Categorical is descriptions of qualities or characteristics, almost as if it is a qualitative data. Numerical variables are numerical characteristics, so that is qualitative. Parameter is just the quantity that's measuring the aspect. Statistic, and you have distribution. Distribution can be a symmetrical bell curve. It can be positively or negatively skewed as well. Outliers. This means that the general body of data, either a point is far out or far in, away from this general body. So those points are called outliers. We're going to look at numerical variables first. Numerical variables can be categorized as discrete or continuous. Discrete is something that you can count, so they're integers, like 1, 2, 3, 4, 5. Continuous is a range of variables. So an example of discrete is that the number of people in a car, you can count, there are 3 people in the car, 4. Number of votes for Trump in California, you can count them up. Continuous, you can't count them up, so you just have a range. So an example is the shoe size of female ages 12 through 18. So they might have shoe sizes within a range of 33 to 41. Or speed at which someone runs at a marathon. It's not going to be the same speed throughout, right? So that's going to be a range as well. Frequency tables are used to describe numerical data. So if, say, you were given all these different values, 1, 2, 3, 4, 5, and you had people vote for these values. This should be in a better context, but say you have 8 people that voted for 1, 2, value 2, you have 9 people, etc. So these are called frequencies. You add all these frequencies up to total up to 30. In order to calculate percent relative frequency, it's kind of like in science when you have to calculate percent errors or any type of percents. So what you do is you use the individual value over the total. So the individual value, for value 1, the frequency is 8. So you use 8 over 30. For value 2, 9 over 30, etc. And you multiply each of those fractions by 100 to figure out the percentage. Numerical data is categorized as column or frequency histograms. Column graphs are discrete data. Do you see how each of these are individual columns? They're not stuck together. Continuous data, because they're a range, so they're going to be overlapping ranges. So that's why the bar graphs are connected. They're not apart. So that's why there are no gaps. Let's take a look at an example. So let's say each month your Labrador, Honey, has gained these amounts of grams. So first, organize the data in a frequency table, state the model class for the data, and describe the distribution. State the model class for the data just means what's the mode for the data, and describe the distribution. So most likely for this case, you're going to have to draw out a frequency table and graph it out. Let's give it a shot. Okay, so most likely you should have used a frequency table that is continuous, meaning that your values, you get to decide your range of values, But the reason why it's continuous is so that it's easier for you to graph it. And the x-axis looks very much, the axes labels are very equal, as opposed to just using negative 0.2 and then positive 0.3 and 0.5. They're not equally apart, right? So we can set the values. For example, I decided to use 0.5 increments. So I started at negative 0.5 because I have a negative 0.2 grams. So in order to consider that weight gained by the Labrador honey, I use 0.5, negative 0.5 to 0. That's one frequency. 0 to 0.5, there are 5 values, as you can see on the left, that reside within this range, etc. You notice how I make it continuous by allowing the smaller number of each of the value ranges to be less than or equal to whatever gram is within it. So this means that the bigger number in your range does not have an equal, but the smaller number has a less than or equal to. That way when you graph things out, as you can see in this one, they're connected. In this graph, then, we essentially graph the value, which is on the x-axis, so that's the grams, and then the frequency on the y-axis. The model class, which would be the mode, you can tell would be the highest peak, right? So that would be the range from 0 through 0.5, as shown on the arrow. And we can see that this distribution is positively skewed. Positively skewed just means that majority of the data sets reside on the positive side, right? You see how after the peak, there are more data on the right-hand side than the left-hand side of the graph. There are a few ways we can measure the center of data. Center of data is just the dispersion or the spread. So in order for us to find that out, we can use 3 ways: mean, median, and mode. Mean, as you guys should know, is the average, which is the sum of data values over the number of data values. So this can be represented by variables. Mean is the variable mu equals to the sum, which is the big sigma, of data values, and data values are x. It ranges from I equals to 1, which means the first value, all the way up to n, the nth value, the 100th value. And because it's the 100th value, whatever number that is, it's out of 100. So you have a total of 100 numbers, so you put that in your denominator. In your median, median is your middle value of your ordered set. This means that in odd situations, if your data set has 31 variables or values, then it's an odd number. You can cancel out the left and right equally, and then you're gonna end up in the middle in one of the original data values. When it's even, it's not going to be the original value within your set. So what you do is you figure out your total set. Say you have 30 numbers, 30 plus 1 over 2, and then whatever number that is, say 31 over 2, then that's going to give us 15.5. Then figure out what number resides between 15 and 16. Okay, and then mode is just in discrete, it's the most occurring number. In continuous, it's called the model class. So just now in our example, we saw that the question asked for model class. So when you see that key vocabulary, you know that in your graph and in your frequency table, it should be a continuous frequency table and a continuous graph. So mean and median can be resistant versus non-resistant. Median is considered non-resistant because median does not rely on the extreme values. So if you have negative 1,000 and positive 1,000,000, those two values are not going to affect the middle number. Mean, that's going to be affected, right? If you have a really big number, then that's going to move your mean more towards the positive side. If you have more negative number, a super extreme negative number, then that's going to move your average towards the left. So that's non-resistant. So that's why you can have positively skewed distribution and negatively skewed distribution. Positively skewed just means that you have more values tending towards the right side of your peak, so towards the right-hand side of your mode. Your mean is going to be more positive because you have more positive values, so that the mean is going to be on the right-hand side of the median, on the positive side of the median. Negatively skewed means that your mode is going to be a peak that looks like it's tending towards the right because you have so many values on the left. That means that your mean is going to be on the left-hand side, on the negative side, more left of the median, the middle number. Let's take a look at how mean, median, and mode can affect the symmetry and whether or not symmetry depends on mean, median, and mode. So say we have this data set of these data values, 3, 4, 5, 6, all the way to 9, and each one of these data values have these many frequencies. What we do to calculate mean, median, and mode is we first find the product, right? So you multiply 3 with the frequency 1, so that gives us a total of 3. So that's X and F multiplied together, product. You add up all the sum of product and you add up all the sum of frequency. That tells us the mean, median, and mode. So mean would be the sum of product, 278, your total values, over the number of values. You have 40 values, so divided by 40. Median, we can see, like what we said just now, this frequency, we only have 40, we have an even number of values, which means that we're going to have to do some calculation. So it's going to be n plus 1 over 2, so 40 plus 1 is 41 over 2 equals 20.5. We're going to look at the data value and the frequencies. 20.5, then it means that your actual data value is going to fall between the 20th number and the 21st number. So you need to figure out where's the 20th number and where's the 21st number. The 20th number happens to be in the 15 frequency of the 7 data value. So that's going to be 7. Your 21st number is also in that same row, so that's also 7. 7 plus 7 over 2 gives us 7, so that's why our median is at 7. Our mode is at 7 as well, and that's because we have the highest frequency there, right? We have 15 of 7 data value, as opposed to 3 1s. 1 3, sorry. So from this, we can see that not all graphs are symmetrical if mean, median, and mode are equal. We can see that there is a skew, right? There is a peak on the left hand, on the right hand side, tending towards positive, and then we have data values on the left, and we have 2 data values on the right. So this tells us that even if mean, median, and mode are equal, if they're all equal to 7, that doesn't mean that this graph is completely symmetrical. So you have to graph it out in order to see that. Lastly, when your values aren't discrete, like just now, the data values are 3, 4, 5, 6, those are discrete countable numbers, right? Say it's the mean of following ages of bus drivers. Then this means that the ages are continuous. So when you have a continuous data, how do you calculate the mean? So what you do is you find the midpoint of the ages. So from 21 through 25, the midpoint is 23, age 23. So you use the midpoints and you set that as X instead. Just now, remember we saw the product was F multiplied by X, so we multiply frequency with X again. Instead of multiplying 21 through 25, we just multiply 11 by 23. That gives us an average value. We add up all the frequencies, we add up all of the products to sum them up. So we have a sum of frequencies of 137 data values. We have f of x, the products, a total number of sum of values, which is 5,161. The mean can be represented by mu, or it can also be represented by x with a line on top of it, okay? So then we just use product over the frequency again. So it's 5,161 divided by 137, and that gives us 37.7. So again, when we use midpoint data is only used when the data table that we're given, or the data that we're given, is continuous data. When data given to us is discrete data, numerical variables, these are all numerical variables, then we don't use midpoints. Okay. So this is the end of this chapter. This is in the textbook 20A and 20B. And let's try some problems out.